geography. I'm a dermatologist and I work in a small city close to Milan, Varese, and close to the company that produces this laser. For this reason, probably I have frequently relationship with the research and development department of Quanta system. But coming back to my topics, some years ago, the company, the industry, introduced in the market the Picosecond technology for the treatment of the tattoo, for the tattoo removal. But soon, the physician discovered the possibility to use this technology for other applications. For example, for the treatment of pigmented lesion and for the skin restoring. In this chart, you can see the great difference between the two co-switcher technology, the nanosecond and picosecond technology. As you can see, the picosecond technology works with high quantity of energy in very short pulse emission mode. But to better explain this complicated concept, I use a trick. If you compare in another metrical scale, laser that work in second and laser that work in picosecond, is like if you compare a yacht with an elephant. But if you compare the quantity of watt of different lasers present in the market, laser that works in watt and in gigawatt, it's like if you compare a needle of mesotherapy, this is megawatt with Burj Khalifa, or this is gigawatt with an Everest. Inside of picosecond laser, you have Everest of energy. But following an old payoff of another Italian brand, the power is nothing without control. And this is exactly what's happened. Because if it's true that working with high quantity of energy in short emission mode, you are able to create the photomechanical effect inside of the target. So you are able to induce a high pressure in small molecular size, around 2 bar, working with very short pulse duration. Is absolutely true that sometimes so high quantity of energy that you are using create plasma. And plasma sometimes is a barrier for the laser light penetration. Follow me, because this is very interesting. Joule fluence. You can create fluence working with watt per time divided square centimeter. So you can create high fluence, high quantity of joule, working with high pulse duration, working with high quantity of watt, but every time you increase the spot dimension to promote great penetration of the laser light, you reduce the fluence. So if you decide to work with very short pulse duration, if you fix the pulse duration, the pulse weight, and you work with large spot size, the only solution to have enough fluence is work with high quantity of watt, high quantity of energy, but you create plasma. Okay, so which was the challenge? To create the best photomechanical effect by various picopulse weights, working with the same quantity of energy. So we decide to investigate the possibility to add in the picosecond emission mode, in the picosecond domain, 2 more pulse weight. So actually, inside of the machine that you can see, there is 4 different pulse weight. 3 in the picosecond emission mode, 450 and 374, 1064 and 532, 600, 750, plus nanosecond. And in our opinion, the possibility to modulate the pulse wave induce a lot of advantages, clinically speaking, especially in some applications. The first of all, I will speak about tattoo removal, because working with the possibility to find the most suitable tuning induce better clinical outcome. I know, and you know, that when we speak about inks, we speak about very small particular size. More of the most ink present in the market has very small dimension, less than 100 nanomicrons. So we are speaking about nano size range. But when you introduce pigment inside of the skin, and this is the quantity that you need to tattoo, to pigment the skin, 250 milligrams per square centimeter. When you introduce these small molecules inside of the skin, you have a clusterization. And you can find big agglomerate of pigment, around 0.5 to 40 micrometer So the target is bigger respect the particle size of the ink. And to have a very good results, you must reduce this dimension in very small particular size to remove the correct phagocytosis and the correct cleaning of the skin. So I am telling something of strong. After years of clinical experience, of my personal clinical experience, I consider 450 picosecond and 1064 nanometer a clinical limits for the removal of black tattoo. So I'm telling that what I told you in the past was not completely true. Why? Because we discovered during our clinical trial that every time we work with high quantity of energy, high quantity of fluids, we create plasma on the surface of the skin. Plasma induce a resurfacing of the epidermal layer. So, and in the same time, this ablative effect reduce the penetration of the light inside of the real target, that is the pigment. So, in my opinion, in our opinion, matching pulse duration to ink particle size is the pathway to promote a transepidermal pigment removal in the first session. So when you have big pigment, so you have great agglomerate, probably nanosecond works better. When the dimension of the target is reduced, probably sub-nanosecond works better. When you have small particular size, picosecond is the best solution, is the gold standard. So the possibility to have in the same machine the 4, 5 different emission mode give you the possibility to treat the tattoo in the best mode. First session with nanosecond, second session with sub-nanosecond, 700 picosecond, and the third and fourth treatment with picosecond emission mode. Again, the same procedure, nanosecond, picosecond, sub-nanosecond, and picosecond. Again, here, in the first treatment, we use nanosecond. In the third and fourth session, we use sub-nanosecond, and in the last session, we use picosecond. In only 8 sections, we are able to achieve these clinical results. Okay, and for pigmented lesion, the situation is similar, right? Because every time we use nanosecond technology, we are very active. We are absolutely very active. But as you can see in this histological image, working with nanosecond emission mode, you induce a disruption of the epidermis from the dermis. You create this separation, this partial separation. And this means that you are creating a lot of inflammatory reaction. And especially in some skin type, Asiatic skin type, inflammatory reaction represents a big problem. It's not an issue, it's a problem. Because every time you can have hyperpigmentation. So the idea, when you use picosecond technology, this separation is not present. You can see the action on the melanosome, you can see the vacuolization of the melanosome, but there is not any separation of the epidermical and dermis layer. So the inflammatory reaction is put under control when you work with picosecond technology. The problem was that if you have so great target, if the lesion is so pigmented, also picosecond emission mode, when you work with so short pulse duration, 370 picosecond mode, could be too much aggressive. For this reason, we have introduced the sub-nanosecond mode. This is the results that you can achieve working with the sub-nano picosecond emission mode, different type of lesion, different type of thickness of the lesion, and different quantity of pigment. In this case, we are treated with 3 different emission mode, the pigmented lesion, and the final results, in our opinion, could be acceptable. But where we saw an amazing application of this technology is in the Pico plasma resurfacing. You know that working with fractional picosecond, we are able to create LIOB inside of the dermis layer. But during our experimental trial, we discovered that when we increase the level of the fluence, unfortunately, we create plasma on the surface, we create resurfacing of the dermis layer, and we reduce the penetration of the LIOB. So every time we need works with high quantity of fluence, working with short emission mode, short pulse wave, we create plasma. And plasma reduce the penetration and reduce the formation of the LIOB in the deep dermal layers. This is exactly what you can see with when you work with 1.4 joule. The LIOB is very superficial, and you can see the resurfacing of the surface. When you work with less quantity of fluence, you don't have any resurfacing of the surface, and you have deep formation of the LIOB. When you work with very low quantity of fluence, you have formation of LIOB, but very, very superficial in the papillary dermis layer, close to the epidermical dermical junction. So, which was the goal? The goal was to create with high fluence, big LIOB in the deep dermis layer, where we won't have an interaction in some clinical pathology and aesthetical condition. And how to obtain this? Exactly increasing the pulse duration. So working with the same fluence, but increasing the pulse weight of the picosecond laser emission mode, we are able to create the LIOB deep in the reticular dermis layer. So working with this system, we can remove the skin restoring of laxity skin. We can remove the association of pigmentary lesion treatment plus the skin tonicity. Or we can treat the scar. This is a scars induced by a wrong laser treatment. You can see before and after with the Picosecond fractional technology, or, and I'm totally agree with the speaker that spoke before than me, the possibility to use the fillers, the AHA filler, like a biological scaffold, create an amazing opportunity for the future treatment of the linear, traumatic, and acne scar. And this is the results that you can achieve after 1 year. Thank you for your attention.